Welcome, everybody. It's a big pleasure to be with you guys again in another webinar. We're very honored to have Lilong Chai from UEA. I met Lilong last year in a summit, animal welfare, and since then we have been in contact and we have been sharing a lot of ideas how to provide a lot of education to the industry. And we're very excited to have Lino today. Like always, this webinar will be recorded, and the name of the webinar is Precision Farming Technologies for the Monitoring Welfare of Cage-Free Hens. So, Lilo, the term is yours. The presentation is going to be around 35 minutes, and then if somebody has questions, be free to ask them. Thank you, Lilo.
Okay, good afternoon, everyone. Thank you for the invitation from Poultry School. My name is Lilong Chai. I'm associate professor and engineering specialist in the Department of Poultry Science at UGA. And my lab is working on several projects, air quality, animal environment, and precision farming. Today, I'm glad to talk about precision farming technologies such as machine vision for monitoring welfare well-being of cage-free laying hens. United States is world number two egg producer. Current flock size about 312 million. Um, that's a flock size is smaller than the regular size of 330 million because avian influenza outbreak. In the past 2 years, bird flu has killed about over 100 million laying hens, but the market is keep recovering, so the current flock not so bad. The primary harvesting system in the USA include the conventional cage system, cage-free aviary system, free-range system, enriched colony. The enriched colony system has only 1% or less market, and that is a primary system used in European Union countries after the banning the conventional cage production in 2012. But the EU country wanted to go to cage-free as well. In the USA, the cage-free market was only um, 5-6% 10 years ago. Now, the market share was close to 35% because primary food chains like McDonald's, Walmart, Kroger, they want to go to cage-free because they think cage-free has better animal welfare. Indeed, in the cage-free facility, the bird has more freedom to move around, to fly, to perch, to perform natural behavior like the spacing, foraging. But current cage-free operations has a lot of welfare issues. Like birds on the floor, they are free to fight each other. So packing damages is an important issue. That's why cage-free has like almost double the mortality compared to the conventional cage production. Other behavior issues, welfare issues include piling, uh, bump food because birds are on the floor, their food pad is contacting the litter flow. The litter quality is bad, so they tend to have food pad dermatitis and bump food. My lab at UGA is using machine vision technologies to address those kind of animal welfare issues. Currently, we have developed different methods for monitoring their welfare and behavior. Technology we are using is called a machine vision technology. This technology has a different part. The important part is computer vision, use a computer, GPU computer to analyze chickens video. Like we collect the videos from by using cameras. But the cameras cannot tell is that a chicken, a duck, or goose. So we have to train the computer. We label the chicken picture, tell the computer that's a chicken, and also we label the chicken's behaviors to tell computer this is a drinking behavior, feeding behavior, packing behavior. So that process is called model training. After training the computer models, the model actually is deep learning network. Uh, Previously, we also use some machine learning method, but that is not applicable for complex tasks. So currently we are using different deep learning models and also some newly developed larger foundation models like a Meta AI's segment anything model. And we try to use that kind of model to improve the detection or monitoring accuracy. After model validation testing, we can apply the model as a tool to analyze chickens' videos. The first task is detection. We had to detect all the chickens on the floor. Then we can tell what chicken is doing. Currently, my students have developed a model for detecting up to 200 birds at the same time. After we detect each chicken, then we will analyze what chicken is doing. So there are some simple behavior, feeding, drinking, very easy. So some problematic behavior like packing is what we are looking at, because packing is one of primary reason why cage-free flock has double mortality. Packing happening in both caged and a conventional cage system and cage-free. But in conventional cage system, six birds are in small cage. They don't have enough space to move around. So if a bird is packed with damage, the bird actually could hide back. So the bird won't be packed by other bird further. But in cage-free system, differently, if one bird is packed with blood, so all other birds can pack the same bird. In hours, the bird will be killed. So that led to severe packing and cannibalism. So I was reached by farmers, egg farmers, to see if we can address the issue. One way we are thinking is automatic monitoring or detection of packing damages. Actually, that is very easy because if the bird has blood, the color of the feather will be different from other birds. So that based on the blood, we can use that as a more clinical sign to track the bird with packing damages. Over these kind of pictures, we have reached like 85% to 90% accuracy in detecting the packing damages. Also, we would like to monitor the packing behaviors. For example, if we see the packing damages and also the head motion. So for example, this bird was packed by the other two birds at this time. So one every motion of packing will be quantified. So we can quantify how many packings in a chicken house a day. By doing that, actually, we can tell the difference between chicken houses. For example, if you have 5 chicken houses, one house has significantly higher packing than other chicken houses. That means something wrong because packing is affected by environmental factors like the light intensity. If the light intensity in the house is higher than recommended, so the bird tend to be aggressive. They like to pack more. If the ventilation is poor, the air quality is bad, like a very dusty environment, the birds would be frustrated, so they tend to pack more. Um, Actually, packing is we consider is natural behavior. We don't want to stop 100% packing. Instead of packing on bird, we can encourage bird to pack on the enrichment, like a packing block, packing stone. And some commercial farm, turkey, broiler, or layer, they are using the packing block, but no scientific research has been done systematically. So my lab is also testing different kind of packing blocks to see how the materials of the packing block affect the packing behavior, how the how the color, maybe we notice the bird like pack on the red color. So by improving the enrichment design, actually we can uh, improve the enrichment design so we can uh, reduce packing damage and improve animal welfare. The other application of machine vision is dead bird detection. No matter in broiler house or cage-free house, we want to get rid of dead bird as soon as possible. But the first thing we have to find the dead birds. So the dead bird detection is a very important task. Traditionally, we rely on the farmer staff to walk around chicken house to look for dead chickens, but that is time consuming, subject to human errors. So if we can use a camera, actual camera is not a rest that it can monitor chicken house 24/7. So if we can use a camera to find dead chickens, that'd be great. And to improve the accuracy, so we use the machine vision technology will label the dead bird behavior pulse, so we can actually detect that chickens up to 95% accuracy currently. And we also just complete the project by using a robotic system like robot walk in chicken house to find dead chickens. That is more efficient. Misaligned behavior and flow eggs are a headache for a lot of egg producers. The kid-free house chicken lay eggs everywhere. So they have to hire a lot of people to collect the flow eggs. If you don't collect flow eggs timely, the eggs could be contaminated by bacteria on the floor. Also, some bird can damage the eggs. So that is also food safety concern as well. So currently, there are no efficient method we can use. So I'm thinking why the bird lay eggs on the floor. So my lab is mimicking the environment in the cage-free facility. We built the cage-free facility in the research on the research farm at UGA to identify why the bird lay eggs on the floor, where is the popular place. Here's the video. And according to this video, like the bird like this corner because this corner is darker a little bit. The litter is softer and deep. So the bird like that kind of place. And they are competing this spot for laying eggs actually. Besides mislaying behavior, we also find some bird waiting for nesting box very patiently in front of chicken nesting box. So for example, this lady is waiting for nesting box very patiently. From a genetic standpoint, maybe we can improve the genetic selection. For example, this bird is a good consideration for future hatchery breeding work. Beside misaligned behavior detection, we also applied machine vision to detect how many eggs on the floor where the eggs are. And based on that method, we can identify the reasons. For example, we found litter quality and light intensity are two primary reasons affecting uh, two primary management factors affecting the mislaying behavior and the flow eggs. For example, over this picture, a lot of eggs are found beneath the aviary system where have dark environment because the light intensity was low over there. So it's nature for bird to find a safe place to lay eggs. Also, we can quantify how many eggs on the floor. That's important to make sure the farmer staff don't miss floor eggs. If some eggs are missed, the bird either damages eggs or hide eggs beneath the deep litter. So if a hidden egg was found 1 month later, farm staff cannot tell if that egg laid today or laid last month. So if the 1 month old egg go to your dining table, then it could be for safety concern. Like I said, light intensity can affect the misaligned behavior. So some commercial farm, they're very smart. They uh, work with the lighting group to improve the lighting management on the floor. For example, they added some lighting system beneath the aviary system. By doing that, they can reduce the floor eggs by 70–80%. Very impressive. But there's still a lot of floor eggs on the open area. So my lab tested a robot in a broiler breeder house. Actually, broiler breeder house has a lot of floor eggs as well. We use a robot to walk around the chicken house, and that can reduce the floor eggs, but the bird laid more eggs on the sled in the breeder house. So we have to consider um, how to improve the design for the egg picking automatically in the future. Piling behavior is another reason leading to high mortality. There are many reasons that can lead to piling, like cold stress may lead to a piling and uh, a noisy environment, like fence running suddenly, and farmer staff's operation. And also recently, according to our studies, mislaying can also lead to piling. For example, a group of birds are competing this spot to lay eggs on the floor. They are competing. So that lead to the piling behavior as well. So no matter which reason, we want to identify piling behavior uh, as fast as possible so we can actually provide, sorry for that. Okay. So we can provide a suggestion for the farmer staff to to expel the bird from the pile as soon as possible, because at the bottom the bird could be killed because of pressure, because of heat. The accumulated heat can kill the bird at the bottom. So our model can be used to monitor piling behavior, and we have reached 90% accuracy on that. No matter, not only in the broiler house, we heard a lot of foot pad dermatitis in the broiler house because broiler chicken litter are very wet, and the bird foot pad could get lesion, get dermatitis. Actually, for the laying hens and the broiler breeders, they have this kind of issues as well. In our research house, we develop a device, automatic system. This platform, if the birds fly on the top, perch on the top. Actually, we have GoPro camera at the bottom, can take a picture like this automatically. And by training the model, we can actually detect foot pad dermatitis automatically. We can also score the foot pad automatically based on uh, the references. So now we are considering to apply the technology to the broiler chicken houses. Bumblefoot is a type of foot pad dermatitis. This primary for the layers and the cage-free breeders. Usually the bird has a long-term stay in the chicken house. For example, in the cage-free facility, the bird will stay in the house from like week 20 to week 66, 70. So the long-term context of the feet and the litter may cause the bumper food depend on litter quality. It's hard to monitor litter quality automatically, but if we detect any chicken food with a bumper food profile, for example, this picture, the picture B, one food has is normal, another food has a bumper food infections. So based on the infection, the profile, actually we can easily label the picture and train the computer models to tell which feed has bump feed, is a bump feed, which feed is not. So we can do that automatically. If we detect a chicken house with a lot of bump feed issues, that means the litter quality maybe need to be addressed. The spacing is normal behavior for cage-free layers, but if the bird stop doing the spacing, that means something wrong. So one of my students is working on the spacing tracking automatically. For example, on the floor, different area, we monitor chickens the spacing behavior. If the chicken not doing the spacing in some specific area, that means something wrong. For example, we notice some area with a wet litter, like a litter close to caked condition. So the bird will never do the dust bathing on the caked litter. The caked litter, the quality not good, very solid, very hard. So bird don't like that place. So based on this behavior, actually we can tell if if the chicken house has litter quality issues or not. We also apply them to monitor brown hens. And for example, we are monitoring the flow distribution panting in this study. If some area don't have a lot of chicken, but a chicken like other area, for example, this picture, we have higher density chicken in this area compared to other places. So that means birds has a preference to stay in some area. So the area the bird don't like means something wrong. So we have to check the location timely to check if that because of light intensity or because of litter quality. So this is a very efficient method. Previously, we are using one deep learning model for one behavior monitoring, but that is very time consuming if we want to do a lot of behaviors monitoring. So one of my former students developed method to do multiple objectives task detection by developing a model package. We can actually, by scanning a picture or a video, we can tell what chicken are doing, feeding, drinking, like perching, pecking, displacing, burning, foraging, laying. So we can do multiple task detection. By doing that, we can reduce the time consuming for the data analysis. Actually, long term, we would like to develop a database. For example, the database has training the images. We can share that to the general public, especially some new company, startup company. They would like to develop some deep learning technologies for poultry production use. They can use our database, so they don't have to raise chickens from beginning. That the flock chicken management is a very time-consuming task. So we would like to work with industry on this kind of research. We also use different larger foundation models recently. Larger foundation model means the model is developed by AI company by using larger models. For example, ChatGPT is a large foundation model, and also Meta AI has a lot of foundation model called segment anything model, fragment anything model. The good thing about their model is they have done a lot of training already. So we are just using a model to detect our chickens. For example, we have orange picture in the A picture by using the foundation model directly, so we can get a segmented pictures. So all chickens, all the object have been segregated actually. So by extract the chickens pictures out, that will save us a lot of times. We usually use a lot of time to train the model, segment the pictures. So by using this method, actually we can save a lot of times, especially for the top view pictures. Every chickens are segmented automatically by this kind of model. But there's still some limitation. For example, if we have two, three chickens piling together, it's hard for us to tell that one chicken or two chicken. For example, two chickens over here, three chickens actually are compiling together. So the model didn't tell how many chickens. So we had to do a further modification programming work. We can add our own model together with the larger foundation model to improve the uh, production, the performance of the model. We are still working on this kind of model. Besides 2D, 3D cameras, we also used thermal cameras. This is a case study. We use thermal imaging technology in a commercial cage-free house. In the chicken house, we use different thermal cameras, one for taking pictures, one for taking videos. So we know which one is the right chicken, so we can track the individual chicken. For example, this picture means the bird based on the head, the panting behavior. If the bird are in, in heat stress, they tend to do panting. Panting is open mouth to breath. That's the primary of evaporation cooling method because the bird don't have a sweating system. So by respirating, they can increase the heat exchange, latent heat exchange. By monitoring that behavior, we can sprinkling the water on the chickens. Usually, there are a lot of chicken house in South Georgia, Arkansas. They have a sprinkler system, but in the cage-free house, especially in the Midwest, there are no evaporation cooling system. So this method is very meaningful for addressing heat stress. By spraying the water on the bird temporarily, just 20, 30 seconds, actually we can reduce the surface body temperature by 7 Celsius or 12 Fahrenheit degrees. That's very impressive. Our thermal imaging method can also monitor flow distribution pattern. For example, the deep picture shows a lot of birds are congregating together. That means the bird are competing for the dripping cold water from the ceiling. So we can actually tell the farmer stuff to flush water line if they see these kind of behaviors. By flushing the water line, we can provide cold water for bird to drink. Some farm also provide a bird with vitamin and other nutrition strategy to help the bird fight against heat stress. Recently, my lab has applied the machine vision to monitor wild birds. Why? Because wild birds is considered primary carrier of bird flu. Because biosecurity has been well implemented in a lot of production system, but bird flu still uh, be passed from one place to the other. We believe the wild birds, especially like waterfowl, play a role. So I told my student to put a camera in our chicken house. Let's see if any water birds. Indeed, we found a lot of water birds approaching our farm, uh, stopped at our place, our farm, because the farm has smell. The ventilation system can pass the smell of the bird to the surrounding environment. The feed smell, chicken smell may attract wild birds to get close to our chicken house, but that is not good for their biosecurity. So we wanted to use this system to detect wild birds automatically. We can tell how many wild birds are approaching, which type of bird are approaching. Actually, based on the machine vision technology, we can just train the model to tell which birds is that got well or other birds. And the next step is developing an alarming system for scare the wild birds away. So in that way, we can use this technology to protect our farm from getting the bird flu carried by wild birds. I talked a lot of individual technology, 2D, 3D, thermal imaging technologies, but it's hard for the producers, ag farmers to adopt. So systematically, we have to develop a integrated system. Like my plan is develop an integrated monitoring system and app for the producer's consideration in the future. This system will have three parts. One is data collection. We use cameras, but in the research house, we use sitting camera that can only cover a limited area on the floor. But in the commercial system, they are very large area. Like a commercial farm has 500 foot long, about 100 feet, 150-meter long, 40-meter wide, so large space. One camera, even like 50 cameras cannot cover the floor area. So my plans use a mobile imaging system, use one or two camera move around the ceiling of the house, so we can collect data, uh, maybe timely. We don't have to collect data 24/7. Just maybe select some specific time, like after light on, that's a good time to monitor the bird behaviors. If the bird has leg issues, if the bird has all the dead chicken on the floor, if they are not moving at all, we can say, okay, that is a dead chicken or problematic chicken. Also, the system will carry navigation system, so we can tell the farmer stuff where the problem, where the issues is spotted, so they can go to the specific location to find a dead bird, find the pack damaged bird. And the important part actually the data analysis. For data analysis, we needed to use deep learning models. The regular model maybe not working. We have to adopt uh, different large foundation models. I'm not a computer scientist. Most of my students are animal science background, so we work together as a team with computer scientists and engineers. So we work together as a team. We're not developing anything from scratch. For the model, we are borrowing that from existing model from a computer world, so that will save our time. Beside the models, another important thing is the computing power, GPU computers. That's why NVIDIA is so rich in recent years. Their GPU sales are very good. We use a lot of GPU as well. And by using GPU computers, we can improve our data analysis. Even my lab have 4 GPU computers, not work good enough. So we got a sponsorship from Oracle. So in the past years, we are using Oracle cloud computing. So we can upload our data to the Oracle computing system. Their supercomputers is very powerful. So by using their supercomputers, we can increase our data analysis speed and also reduce our our research cost. In long term, actually, we wanted to encourage the farmer to use that because I talked with a lot of producers. No one wants to use the computer by themselves. They like to invest some money to buy the system, but they don't want to operate their computer because that is complex task. So in long term, we can develop everything like a black box. So let the data be collected automatically, uploaded to the cloud, so that we use the cloud computing to get data analyzed timely. Then we can share the information in the app. So all farmers, producers, they like use smartphone and the app so that we can share the data like welfare status indicators, packing damages to the app. So the farm staff, farm producers, they can check their farm situation timely. Then they can give the feedback to improve their management, to improve their animal welfare management. That's our long-term plan. For those kind of technology, it's not a very easy to learn beginning. So we have to provide a training for the layer or broiler producers, farmers, and also a lot of research. So annually in UGA, I'm coordinating two conferences. One is called Precision Poultry Farming Conference every May. Our next conference will be May 6th. Another conference called Georgia Lake Conference every September. So in the past 4 years, our conference has trained over 2,000 attendees from 50 plus countries. Not only myself, but also I invite a lot of famous people to give talk. For example, at the Precision Conference, I invited Dr. Daniel Berkemans in Belgium. He's considered the father of precision livestock farming. And also here, Dr. Marion Dawkins from UK, our professor at Oxford. She's considered pioneer in animal welfare world. We also invited a lot of iconic people from industry like Tyson Food, Animal Welfare Senior Director, COP Senior Director, and also we have for laying hens, we have USDA leader from like Dina Jones, and we have United Egg Producer CEO, Chad Gregory. We have so many famous people to share their opinions, new technologies at the conference. And we would like to share the information so we can get a feedback from the industry, from the stakeholders, how to improve our precision farming work from our laying hen production. Take-home messages. The machine vision technologies I mentioned may be applied to address the current animal welfare issues in the cattle-free system, like severe packing, mislaying, piling, and the precision farming is a teamwork, as I mentioned, that requires a collaboration between researchers, industry people, farmers, computer science, and economists as well, because the AI technology is not cheap. Like GPU computers or robot, sometimes is cost prohibitive. We have to consider about offset. Just like cage-free eggs, the nutritionally cage-free egg and the conventional cage egg no difference, but cage-free eggs price is much higher because the bird has a higher freedom to move. So in the same way, we have the technology that can improve animal welfare. So we can propose to adjust the price of the egg product or chicken product higher. For example, if the egg price can be increased by 20%, if we are using technology to improve animal welfare, if that is approved by the Walmart, McDonald's, maybe the producers are willing to use the technology to improve the animal welfare in the future. I'm not working alone. I have a lot of collaborators at UGA. Outside of UGA, also rely on my team members. In the past 6, 7 years, my lab has had about 10, 11 students. Most have graduated. They contribute a lot to my research. And I also appreciate my sponsors. From my grant come from a USDA side, also Georgia Research Alliance industry like Zoetis, CAO, Oracle Egg Industry Center contribute a lot to my lab research as well. Also, UGA has a newly founded institute called Integrative Precision Agriculture. I have received 2 rounds of seed grant from the institute to facilitate my lab research to buy sensors, cameras. Okay, thank you very much. I'm glad to answer any questions.
So, Lilong, thank you very much for your presentation. As we discussed before going into this webinar, one of our main goals is to close the gap between all this research that you guys are doing in a very nice way, and how to go into the real farming and how to transfer this technology to the growers. And all these discussions and sustainability, cage-free, animal welfare, and the potent subject right now is AI, that we know that is something that is booming in any other area, not just in the poultry. So part of our vision in poultry school is having this conversation open and to bring consciousness and to open a new dialogue of how to bring education models. And I really appreciate, Lilong, your time and your effort for putting this presentation together. So if we don't have any question from our audience, I just want to share again that this will be accessible in maybe 1 week and a half. And you have all the contacts of Dr. Lilong if you want to reach him. And let's keep doing this work together, guys. Thank you, Lilong.
Yeah, thank you, Rudolph. It's my great pleasure to communicate with your group.
Thank you, guys. Thank you, everybody. Bye bye.